Okay, last time we looked at solving trig equations by looking at graphs or by working with a calculator. And while we won't do the graphs a lot, we will do the calculator more often. However, most often what we're going to do is solve these trig equations algebraically. So that's what we want to talk about today. There are several situations where we're going to need to do this. Whenever there's an exact answer that's required, you're going to have to do it algebraically, because on a calculator you're not going to get irrational values displayed properly, and most of the time the answers will involve roots, square roots, or pi, so a calculator will not give you an exact answer, so you'll have to do it manually. Generally, these problems involve known angles because we know the sines, cosines, and tangents of multiples of pi over 6 and pi over 4, and the answers will involve square roots or surds. Remember periodicity, there's generally going to be multiple answers, and you have to figure out which ones of them fall in the desired domain. So let's take a look at a couple of examples. For the examples below, I'd like you to try them before you watch how I work them. So when I display the problem, the question, pause the video, take some time to work it out, see what you get, work with each other, and then start the video to see the explanation. And the first one we're going to do is sine of x equals minus a half. And what we want to remember is that this means that x is the arcsine, the angle whose sine is negative a half. This is basically what we're doing. But if you put this in your calculator, what you're going to find is that the angle with a sine of negative half is this angle here, negative pi over 6. And sure enough, it has a sine of negative a half. So what we're going to get is that x equals minus pi over 6, right? But if I add 2 pi to that, if I take this negative pi over 6 and add 2 pi, I'll get another angle that will have the same sign. So I can also think about negative pi over 6 plus 2 pi, or if I add 2 pi again, in other words 2 pi twice, I would get another angle that has the same negative 1/2 for sine. In fact, I can add 2 pi any number of times I want. That's one cycle around the circle, and I will still land at the same place that has the sine of negative a half. So I'm going to call this adding 2 pi times k, where k is any integer. K can be any integer, including negative numbers or 0. So this 2 pi k accounts for the fact that I can also add any number of revolutions around the circle to the angle negative pi over 6 and still end up with a sine of negative a half. Now, we also know that there's another angle, and it's over here, that also has a sine of negative a half, and that comes from pi minus negative pi over 6. Every angle that has a sine of alpha corresponds to another angle, which is pi minus alpha, that also has that sign. So in this case, the angle here is going to be 7 pi over 6, and so we have that one too as a possibility, 7 pi over 6. And again, for 7 pi over 6, we can also traverse the circle any number of revolutions, that's 2 pi times any number, and end up with a sine of negative a half. So these are all the places on the circle, infinite number of them, where the sign will be negative a half. So the next thing I want to do is limit now my answers to the ones that fall in the desired domain. This is where you need to read the problem and find out which ones of these work. Okay, so we'll start with these first ones. The minus pi over 6. If I use k equals 0, then I get minus pi over 6, and that's too small, it's negative, and I don't want that one. So the next one is going to be adding 2 pi, or 12 pi over 6 is the other way to think about that, because we're adding in sixths. So 12 pi over 6 minus pi over 6 is 11 pi over 6, and that is the angle that I'm interested in. And it's really the other way of looking at this one. We call it 11 pi over 6. If I add 12 pi over 6 here, I'm going to get 23 pi over 6, and that's bigger than 3. So we are going to ignore it, and we're done looking at this first set, and we only get one angle that falls in our desired domain. For this initial angle, 7 pi over 6, we have that as an answer, and we also have to add 12 to this. Well, 12 pi over 6 plus 7 is 19 pi over 6. That's bigger than 3, and so it's bigger than 3 pi. And so we're going to ignore that one as well, and we end up with just the two answers, 11 pi over 6 and 7 pi over 6. So that's part A. Part B, we're going to look at the same ultimate answer, this minus 1/2, but now we've got sine of 2x. So when we do the arc sine here, like we did up here in the first one, instead of getting x is the arc sine of minus 1/2, we have 2x is the angle, that's the argument here. So 2x is the angle whose sine is negative 1/2, which, as we saw, we've already done this work, are these angles here. So we have 2x equals minus pi over 6 plus 2 pi k, again k is an integer, and also 7 pi over 6 plus 2 pi k. And now we're ready to, not quite ready to do this, because we've got 2x over here, so what we need to do is divide both sides by 2. So let's write that like this. We divide both sides by 2, and what we get is that x equals minus pi over 12, and you'll notice that when we divide this side by 2, we're also going to divide this 2 pi k by 2 and get plus pi k, and 7 pi over 12 plus pi k here. So you look what happened to the pi k. It was 2 pi k up here because 2 pi was one period of sine x. Well, when we divided by 2 here, we get that pi k is the period of sine of 2x. It's the same thing. Remember that when you put the 2x in here, that 2 is the frequency, and the period of this is pi. It's compressed the wave by a factor of 2, and that's why we're adding one period, or k periods, to find the rest of the angles that align with minus pi over 12 and 7 pi over 12. So now we're going to do that and find which of these fall between 0 and 3 pi. So the first one here, when k is 0, minus pi over 12 does not work, but I'm going to add 12 pi over 12 to this, and that'll give me 11 pi over 12. That works. That's a little bit less than 1. And then 23 pi over 12 when I add another pi, and that's a little less than 2 pi, and that works. And the last one is 35 pi over 12, and that's a little bit less than 3. And if I add 12 pi over 12 again, I will be above 3 pi. So I'm done, and these are the three angles I need coming from negative pi over 12 as the starting point. And for this one, I've got 7 pi over 12, 7 pi over 12, and 19 pi over 12. I'm just adding pi in the form of 12 pi over 12, and 31 pi over 12. And those are the 6 angles that fall between 0 and 3 pi, and that solve the equation sine of 2x is negative 1/2. And you'll notice, of course, if we double these, if we double this one, we'll get this one, and these contribute in the same to the same set of solutions when the frequency is doubled. The last one I want to look at is part C, and in that one we don't have a different frequency, but we do have a shift. So let's look at part C. Again, minus 1/2 is the result, and I've already done that work, but the argument now is x minus pi over 6. So I get that x minus pi over 6 is equal to minus pi over 6 plus 2 pi k It's not very good writing, sorry. And 7 pi over 6 plus 2 pi k. And now, to finish, all I need to do is add pi over 6 to both sides, and I get x equals, well, minus pi over 6 plus pi over 6 is 0, plus 2 pi k. And the other one is adding pi over 6. I get 8 pi over 6, which is 4 pi over 3 plus 2 pi k. You'll notice this doesn't change the period, of course, because we're just shifting. This still has a period of 2 pi up here. And now we just select the ones of these, the values of k, that land us between 0 and 3 pi. Now you'll notice that 0 is included because that's a greater than or equal sign. So we're going to have 0 and 2 pi, and we're not going to include 4 pi, that's too big. So 0 and 2 pi, and then we have 4 pi over 3, 4 pi over 3, and if we add 2 pi to that, we get 6 pi plus 10 plus 4 pi is 10 pi over 3, 10 pi over 3, and that's still less than 3, but if we add another 2 pi here, we'll get 16 pi over 3, and 16 pi over 3 is bigger than 3 pi, so we're done. These are the 4 angles that we need. Okay, let's look at another problem now, another example. Let's see what we've got here. Find the exact solutions of that expression equals 0 for x between 0 and 6 pi. So now we just have a little bit of work to do before we can do the arc cosine here. We have a cosine this time. First thing I'm going to do is subtract 1 from both sides and divide by root 2 so that I get cosine of x minus 3 pi over 4, a little bit of algebra, is equal to minus 1 over root 2. And that comes from subtracting this 1 from both sides and then dividing by root 2. And then we think about where is the cosine of some angle equal to negative 1 over root 2, and we know that's a 45-degree angle somewhere, a multiple of pi over 4. The cosine is minus 1 over root 2 in the third quadrant and in the fourth quadrant. So those are the two angles, plus and minus x minus 3 pi over 4, that is. That's the argument. X minus 3 pi over 4 has to equal plus or minus, this is 3 pi over 4. So we'll say plus 3 pi over 4 and minus 3 pi over 4. And each of those has the possibility of adding multiple 2k pi, actually 2 pi k, sorry, multiples of revolutions around the circle. In order to solve for x now, I have to add 3 pi over 4 to both sides. So I'll say x is 3 pi over 4 plus 3 pi over 4 is 6 pi over 4, or 3 pi over 2 plus 2 pi k. That 2 pi k doesn't change, right? And when I add 3 pi over 4 to this side, I get 0 to this one. I get 0 plus 2 pi k, and I'm looking for the values of k that will land these x's between 0 and 6 pi. So let's see, I get 3 pi over 2. That's there when k equals 0. And if I add another 2 pi is 4 pi over 2, so I get 7 pi over 2 and 11 pi over 2. I'm adding 4 pi over 2 each time, and I'm trying to stay below 6 pi. Well, when I add another 4 pi over 2, I'm going to get 15 pi over 2, and that's bigger than 6 pi. So I'm done here. And then with this set, I've got 0, and I include 0 because of the equal sign here. 2 pi, 4 pi, and 6 pi. And that should should take care of that one. Okay, let's look at another one. This time we've got our Ferris wheel. We're going to go back to that and ask the question, can you find the times in the first 4 revolutions when the diver will be 30 feet off the ground? Now, in one of my classes in the E-block, we looked at this one before, so I'm going to go through it again. If you're in E-block, you can skip it if you feel comfortable, but also you could just work it through with me here. So the first 4 times, find the times in the first 4 revolutions when the diver is 30 feet off the ground. We're looking at the times when the height is going to be 30 feet off the ground. And so we're going to first do a little algebra, subtract 65, and I get 30 minus 65 is minus 35, and divide by 50. 30 minus 35 divided by 50 has to equal sine of pi over 20t. Now this one, hopefully you'll notice, is not one that we're going to do without a calculator because we don't know the angle whose sine is minus 35/50th. So we're going to need to get the calculator out. Okay, so using the calculator, the angle whose sine is negative 35/50ths is in radians. I'm going to get pi over 20t equals 0.0, it's negative 0.7753 dot dot dot, a bunch of extra decimals. And if I take pi minus, this is an equal sign here, sorry. If I take pi minus this, of course, because of the negative sign, it's going to be a plus, and the other angle is going to be 3.91699, blah, 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 blah. These are both from the calculator, just using the arc sine of negative 35/50ths. And of course, I'm going to have plus 2 pi k for each of those. So I'll put that here. Plus 2 pi k. Oops, 2 pi k. And then I need to multiply both sides by 20 over pi to get the numbers that I want. So let me do a little more calculator work. And that will give me that t, when I work with the calculator, is going to be, this first one, when I multiply by 20 over pi, I get minus 4.93 dot dot dot. And when I multiply 2 pi times 20 over pi, of course, I'm going to get the period of the Ferris wheel, which is 40 seconds. 2 pi times 20 over pi is 40 seconds, times k, because I can go around as many times as I want. And when I multiply the 3.9 blah blah blah, I get 24.93, these are truncated but lots more decimals, plus 40k. And so the first number, negative 0.493, doesn't work, and so I'm going to add 40 to that, and I get 35.1 rounded to 3 significant figures. If I add 40 more seconds to that, I get 75.1, and I'm going all the way up to 4 revolutions, which is going to be 160 seconds, everything under 160 seconds. So 75.1, add another 40, and I get 115.1, and add another 40, and I get 155.1. And of course, if we were going to round these to 3 significant figures, this one would be 115, and this would be 155. And then for the second set, we get 40 plus, well, we'll get 24.93, which is going to be 25, which is going to be, and for the second set, we're going to take our 24.93 and add multiples of 40, so 24.9 would work. And then if we add 40, we get 64.9, and these are all rounded now. 104.9, and 40 more seconds, 144.9, and those are the times when a diver will be 30 feet off the ground, and 30 feet, of course, is down here. It's up around in here somewhere, and you'll see that there are going to be the two spots. This one corresponds to the, actually this one corresponds to 24 seconds, and this one corresponds to 35 seconds here. When the time, it corresponds to the -5 seconds, more or less down here, but of course we're not going to go into negative time, so it actually corresponds to 35 seconds. That's this one, and then 75 seconds we're here, 115 we're here, 155 we're there, and then likewise over here, that'll take us 24 seconds, or 25 seconds roughly, to get to here, 65, 105, and 145. Okay, we'll try another one here. This time we're going to work with tangent, which is sometimes a little trickier. Got to just remember that the period for tangent is pi, not 2 pi. So we've got tangent of 2x minus pi over 3 is 1, which means that when we take the arctangent, we get 2x minus pi over 3 is going to be the angle whose tangent is 1. So let's think about that a little bit. The angle whose tangent is 1, we draw the unit circle and think about it, visualize this. You're going to get better and better at this. But here's a slope of 1, that's the tangent, and that's at pi over 4. And every pi radians after that. So we can add, if we keep adding pi to pi over 4, we'll get 7 pi over 4, and then back here to whatever the next one is. So we think about the tangent and what angle has a tangent of 1, and you'll get a lot better at this as you go, but the angle is pi over 4, and then also every pi radians after that, if we add pi radians, we'll get to 5 pi over 4, and then if we add pi radians again, we'll get to another angle that is 9 pi over 4, and so forth. So our angle here, the angle whose tangent is 1, is pi over 4 plus pi k now. Be careful with the tangent. It's pi k. And that takes care of them all. We don't have a second one like we did with sine and cosine. And now we're just going to work this and solve this for x and find the ones that are within our domain. So we start by adding pi over 3, and we get 2x is equal to pi over 3 plus pi over 4 is 4 pi over 12 plus 3 pi over 12 over 12 plus pi k, and we work that out, and we get that 2x is equal to 7 pi over 12, 7 pi over 12 plus pi k, and now we're going to divide by 2, and you've got to be careful that 2 is also going to divide the pi k, and we get x then is equal to 7 pi over 24 plus pi over 2 times k. Pi over 2 times k. And now we're going to find all the ones that are between negative pi and pi. And this takes a little fraction work. Pi over 2 is 12 pi over 24. So that's the amount that we're going to add. I just want to get that numerator correct. So we're looking for, let's do the positive ones first. X is going to be, let's see, x is 7 pi over 24. That works. And then if we add 12 to 7, we get 19 pi over 24, and that's still less than pi. So we're good there. But that's it, because if we add 12 more, we're going to be above pi. And the negative ones, if we let k equal negative 1, we're going to subtract 12 pi over 24 from 7 pi over 24, and we'll get minus 5 pi over 24. That's the first negative one. And then subtract 12 pi over 24 again, and we get minus 17 pi over 24. And if we do that again, we'll be less than negative pi. So those are the 4 answers that we've got. Okay, let's try one more. This one, we see we've got both sine and cosine in there, and that might be confusing at first until you realize that, well, I can deal with that because I can divide both sides by sine x and get tangent, or divide by cosine and I can get a tangent out of the sine and the cosine. So first thing I'm going to do, since I want sine over cosine, I'm going to divide both sides by cosine, and I get root 3 sine x over cosine x equals 1. And that, of course, means that root 3 tangent x equals 1, and tangent of x is 1 over root 3. So there was just a little additional step there to take the two trig functions and merge them into one. And you're going to see lots of situations where you need to see what kind of manipulations to do to get to the place where you have just one function that you can then take the arc, the inverse of. So the angle whose tangent is 1 over root 3 is pi over 6, if you remember. So x is going to be pi over 6. And again, for tangent, it's plus pi k, and that will take care of all of the angles that we need. And so all I'm going to do is find the ones of these that are between 0 and 2 pi, and I get pi over 6, and if I add 6 pi over 6, I get 7 pi over 6, and let's see, 13 pi over 6, of course, is too big, and so we are done. And graphically what we're doing here is the pi over 6 is this angle here, and the 7 pi over 6 is this angle here, and those are the only two angles, that one and that one, that are between 0 and 2 pi. So that's it for this lesson, and here's your homework. You'll notice a couple of question bank problems here. Please don't forget to do those, and we'll pick it up next time. Take care.